Hello, everybody, and thanks for inviting me to present the VI paper, Transient Building and Ductwork Airtightness in Germany. I'm not actually the author. The authors are Stephanie Wolfsmeyer from Bloedor and Wolf Rienhardt, and I'm just presenting um, the paper here because, well, Steffi asked me. She is on holidays, so I tried to do my best. Um, well, the pictures that I added in here is a reminder for all of us why we do the test, as we are, what I feel, somehow fixated on figures and not on the leaks. And this is one huge problem that we face here in Germany, that we might have a good value, but still we have leaks that destroy or damage the building envelope, insulation, and so on. So just a reminder for us, the reason why we test buildings or the airtightness of buildings is not just to get a value that we can put in our EP calculation, but to check for leaks, find them, and avoid them or heal them. Of course, that's not in the paper. In the paper is some figures. We have 21 million residential or non-residential building stock in Germany in 2021, and 19.4 million residential and 2 million non-residential buildings. That's what we deal about. We deal with. And one main issue is that the building of new buildings has, well, stalled in the last couple of years due to the pandemic that we had, due to the recession that we have. And we feel that as well in the building testing, yeah, that our members report that they test less buildings because the building market, well, doesn't evolve but stalled. And I think in terms of what is the goal, we need to get to the refurbishment. And in refurbishment, we actually don't have any figures. All figures that we produce in testing buildings are mostly new buildings, and the huge market will be the refurbishment that we all facing all over the world. So actually that's the market, the whole share that we see here. Those buildings need to be improved and tested. So, well, I don't have the timeline as my Estonian colleague had. Of course, well, we started a long time ago. The first benchmarks were set in the EP regulation in 2002, the Energy Buildings Act. Now, well, it has been reformed several times. Now we have, it's called GEG, and it sets requirements to have a certain quality of the building envelope. It needs to be built airtight according the rules of technology. So that's mandatory. You need to build it airtight, but no test is mandatory. That's some kind of, well, how can you be sure to have an airtight building if you don't need to test it? But that's the contradiction we live with, and that we try to, of course, spread out. That is a good way to prove be airtight in order to test the building. But if you test the building, you can set the measured value or default value in the EP calculation. So it's not mandatory, but if you test, you improve your energy performance of the building. if you do not exceed the limit values. The limit values are separated in buildings below 1500 cubic meter internal volume and above. And if you're below, it's the N50 value. You will notice we call it NL50 value. We have the index L because we have a national annex to the 9972, where we have a different volume defined for our national annex that is this is in line with our EP calculation, where we calculate with the internal volume without the inner structure. Just a moment to have the pointer here. We exclude the internal building construction from the inner volume. So the NL50 value for buildings without ventilation will be is 3 air changes per hour. And if you have a ventilation system in smaller buildings, it's an NL50 value of 1.5. You need to, well, you're not allowed to exceed. In larger buildings above 1500 cubic meters internal volume, we reference the air permeability is limited. So the leakage flow is put in reference to the building envelope, and it's 2.5 cubic meter per hour per square meter for buildings with a ventilation system, and 4.5 for buildings without a ventilation system. And of course, we have incentives for the building Airtightness, the funding program of our government, Bundesförderung energieeffiziente Gebäude, funding program for energy efficient buildings. And some programs require airtightness testing. As I said, in EP regulation, it is not mandatory, but in order to get that funding, you need to test. And for all measured, and that is something regarding the point in the EP regulation, you need to build airtight. For all funded programs, you need to have an airtightness concept. So they put the focus on the planning process of the airtightness. You need to plan it, but not for all buildings, you need to test it. In passive houses, you need to test the airtightness, and the benchmarks, as you might know, is 0.6 air changes per hour. The N50 value must not exceed that value. In the DGNB, this is the Sustainable Building Council, there are various limit values depending on the building type and its use. If we go to the energy performance calculation, you notice that the values you put in the equations are quite smaller than the limit values that we have in our regulation. So if you test and you're allowed to set in the calculation smaller values. The value for the N50 value will be 3 for buildings without a ventilation system, or 1.5 for buildings with a ventilation system. And of course, you're allowed to put in the measured value as well. But if you test, you are allowed to calculate with the default value. If you do not exceed, or if your building does not exceed the limits of the EP regulation. So in larger buildings, it's the Q50, and it's 3 for buildings without a ventilation system, or 2 with a ventilation system. If you don't test, you you have to calculate with higher values in new buildings, or class 3 would be refurbished buildings, and class 4 will be refurbished buildings where you have obvious leaks in the building envelope, like leaky windows. Yeah. So yeah, this is as in the introduction, it was said that it is not mandatory to test, but if you don't test, you have to calculate with a higher leakage rate, and this is what I give you in that sheet. I transformed the N50 value in the infiltration rate. Yeah, you see if we have an N50 value of 1, we have an infiltration rate of 0.07, and in the equation for the total heat loss over ventilation, it's an air change of 0.55 that you have to put into the calculation. If you have an N50 value of 10, the infiltration is much higher, but the air change rate that you put into the calculation for the total heat loss over ventilation, it's close to 1. It's 0.1, 0.99. Just to give you an impression. So we have a guideline for testing the building air tightness. We have a national annex, and as I said, our volume is without. We calculate our volume, the internal volume, without the building construction. So our figure is the NL50. We have a detailed checklist, as you see here. Here's the link if you're interested. We have a detailed checklist how to preparate a building for method 3. It is pretty close to method 1, but there are certain things you are allowed to seal if they're not if they haven't been mounted yet. You're allowed to seal the opening for certain for the dryer perhaps, or for the stove. You need to test with under and over pressure, and the pressure drop within the building must not exceed 10%. It was pretty important for us to include that in our national annex. We have in the annex a weighted sample for a weighted calculation and the calculation for the uncertainties of the measurement, as well as an instruction how to do sample testing. It is allowed for arcade apartments in our EP regulation. It is allowed to test arcade apartments with a sample. And it's an instruction to how you do section by section measurements or guard zone measurements. If you need to test buildings in sections, it's described in the national annex. Ductwork air tightness. Well, I'm not really into ductwork air tightness, so I'm just quoting what I found in this VIP, in this VI paper. In our regulation from 2007, EP regulation, there were requirements for energy efficiency of cooling and air conditioning in case of renewal or new constructions, but it does not contain classifications for air tightness of ducts. And you have a limit value for the electrical power of the fans. This is SFP4 according EN 13779. And in our actual EP regulation, the GEG, the EN 16798-3 is referenced, and there at least we have a requirement of class B or class C as a recommendation for the ductwork airtightness. But in funding, there is a requirement for the proof of the tightness of the air duct system. So if you want to get well, if you apply for a funded program, energy efficient building program, you need to test the air tightness of the duct system. But you only need the proof according EN 1507 or EN 12237. And also in calculation, the ductwork airtightness is not taken into account just over the airflow that needs to be, well, increased in order to get the airflow that is owed. And if I read our EP calculation standard, it says the heat loss due to leaks in the ductwork can be neglected if it does not exceed a certain temperature difference. If it's below 10 Kelvin, the heat loss due to leaks in the ductwork can be neglected. So I think we need to work on that ductwork airtightness. There's a lot to improve there. Thank you very much.